Okay, welcome to this video on using circuits in Ohm's law. Just real quick, I wanted to review with you the parts of our circuit diagram. First thing is that we have our batteries here, and at our battery we're usually told some sort of voltage. So let's say it's like 110. We also have resistors, and sometimes these resistors can also look like light bulbs, and we also can see light bulbs that look like that too. So resistors and light bulbs are going to be treated the same for today. And then we also have a current, and the current's usually shown with some sort of arrow labeled with an I, and these are usually labeled with an R. Also want to remind you that we have our three equations that we used last time, where we can solve for V, R, and I. So instead of in word problems today, we're going to actually be looking at the diagrams and get the numbers from our diagrams. So we can get voltage from the voltage written by the battery. We can get the current by something that says I equals, and it's usually drawn as an arrow. Or we can get the value of the resistors in ohms that are usually written right by the resistors. So go ahead and pause this. Draw yourself a circuit diagram labeling where we find the values of R, the values of I, and the values of V. And if you want, write down these equations again. Remember, they were in your last notes. So, but you will need these today, and they will not be on your worksheet. So if you want to rewrite these today in your notes, please do so. Okay. So our first example is going to be solving for current. You will notice that we have our voltages here. So our diagram's telling us what our voltage is in our problem. And we actually have three resistors in this problem now, each with different values. So the first thing we're going to oftentimes ask us is, what is your total voltage? And in this case, our total voltage is equal to 12 volts because we only have one battery. If we had two batteries, we would add the voltages together to get our total voltage. But in this example, we only have one voltage. Next, we need to find our total resistance. Notice we have three different resistors. And what's great about resistors in series only is that we can just add them together. So we're going to add 10 ohms plus 20 ohms plus 5, and we're going to get a total of 35 ohms. Okay? So now, we can find the current. So now what we can do is find the current. And we're going to find the current by using our equation I equals VR. So current is equal to going to be to 12 volts divided by 35 ohms. And when I use my calculator, I get a current of rounding it on my calculator, 0.34 amps. And then I'm going to put a box around that. Okay, go ahead and pause this video and make sure you have this example written down. Okay, so here's our second example. Notice in our diagram right now we have our voltage, but this time it's given as a current. And when we have the current on a circuit diagram, oftentimes it'll show an arrow showing what direction that current is flowing. For all the problems you guys will be solving, it doesn't matter which direction the current is flowing. Just assume it starts at the positive, goes from the positive to the negative. And that's what you need to know. Okay? So, first thing we're going to do is we need to calculate the total resistance. Notice we have three resistors. So what we can do is first use this equation, resistance is equal to V over I, and that will tell us what our total resistance is. Okay, so substituting in, we get R is equal to 12 volts divided by our current, which is 4 amps. So our total resistance is equal to 3 ohms. Notice what I did here is I actually said that that is equal to my total resistance. Now what we need to do is find our resistance of each. So we have 3 resistors. We're going to assume all of these resistors are the same value. So all we have to do for our resistance of each is do 3 ohms divided by 3 resistors, which gives us 1 ohm. So go ahead and pause this, copy this down for your notes, and then resume the video when you're ready to go on to the next slide and topic. Okay, so now what we need to do is review voltage drop. So hold on. So we'll do this in a second. Okay, so we're going to review voltage drop here again. This is something that we worked on a couple different times now, but this is where we actually are going to need it. So what we have here is a voltage of 21 volts. And what happens with a circuit is that the amount we start with is going to go all the way through the circuit and end up with 0 volts at the end. And each time we pass through a resistor or light bulb, it takes some of the voltage away. So 21 volts is going to travel through our little circuit, and right before it gets to that resistor, it's going to be at 21. And then it's going to drop down. And I just happen to know, in this case, that it's going to drop down to 7, and I'm going to end up with 14 on the other side. And I'm going to travel all the way around until I get to 14 right before. It's going to drop down by another 7. And then I'm going to keep traveling around with those 7. So right before I get 7, and then right after is 0. So notice as we travel around, each resistor is taking away some voltage from us. And when we get to the end, it has to be 0. That's one of the major rules of these circuit problems, is that what you start with at the beginning, when you get all the way through, you have to be to 0. Okay, another thing we do to help us keep track of this, because now we have a lot of numbers. So we need to number our resistors. So we have resistor number 2, 1, resistor number 2, resistor number 3. So what we'll get is we want to say what the voltage is across 1, voltage across 2, or voltage across 3. And in my very easy on-purpose example, all of the voltage drops were by 7. Maybe make that a clearer 7. Okay. So to get that 7 for voltage number 1, I did 21 minus 14. What I started with and what I ended with. To get the voltage drop for number 2, I did 14 minus 7. And for voltage number 3, 7 minus 0. Basically, you're subtracting what you started with and what you ended with. What you started with and what you ended with. What you started with, what you ended with. So go ahead and pause this and copy this down, because we're going to use this in our next slide. Okay, so finally, we're at the big kahuna. This is where everything comes together. Notice we have a problem where we have 12 volts. We have a resistance, and this time our resistance is 3 different types. So our voltage drop is actually going to be 3 different values. So just to get us started, so we all agree, I'm going to call this resistor number 1, this resistor number 2, and this is resistor number 3. Then what I'm going to do is I'm going to find my total resistance. This is from our first problem, was 35 ohms. My total voltage is 12 volts, and my current is equal to 0.34A from example number 1. This is the same example from example number 1. So we've already done all of this work. Now what we need to do is find the voltage drop across 1. To do that, I need my equation for voltage. So my equation for voltage is V equals R times I. So my voltage across 1 is going to be my current, which I calculated from before as 0.34. And I'm going to multiply it by the resistance of my first one, which is 10 ohms. So then what I get is a voltage for just across 1 of 3.4 volts. So basically what that is saying is that I've got 12 going in, and then when I pop on over to the other side, I'm going to have minus 3.4. That will be equal to 8.6 volts. But really all I'm asking for is what the voltage drop is. So the voltage drop is this 3.4. So let's see how this is done for another one. Once you figure this out, it actually becomes pretty slick. As long as my program works. There we go. So now I'm going to find my voltage drop for number 2 and my voltage drop for number 3. All I'm going to do is take 0.34 and multiply it this time by 5 ohms. And I'm going to take 0.34 and multiply it by 20 ohms. So when all of this is done, I have 3 different voltage drops for 3 different voltages. What's something to remember, and you're going to see this in your homework, is that the current in a series never changes. Never changes. The current in a series, this is for series only, will be the same no matter where you are in your circuit. It'll always stay the same. So once you've found your current, then you can find the voltages for every resistor by using our equation V equals Ri. So go ahead and pause this, and then this should finish up, and then you can start working on the problems that you have in your notebook today.